If a function f has a relative extremum, when I say extremum, that means it can be a maximum or a minimum. If it has a relative extremum at c, then c is a critical number, or c is the endpoint of the domain. If you think about it, if we have something like this, the horizontal tangent there is going to have a slope of 0. It could also be the case that it's something like this, in which case it could be an endpoint that's greater than all the things in a neighborhood nearby. So here we have a function, and if I look at it, I can see we have a local or relative minimum right here, another one on the other side, and that's because all of the points nearby are higher. Also notice that at this point, the derivative is equal to 0 because it has a horizontal tangent, and the same thing on the other side. Here we have a local or relative maximum, except this doesn't have a horizontal tangent line. It would actually kind of have a vertical tangent line. In fact, if we looked at this carefully, we'd see that the derivative doesn't exist at that point. So if we looked at the derivative there, it would not make any sense. So if we're looking for points like these, we're going to have to check where the derivative is 0 or where the derivative doesn't exist, and that's where our critical numbers are. Let c be a critical number for a function. Suppose that f is continuous from a to b except possibly at c, and that c is the only critical number for f in that interval from a to b. Now here's the key part. F of c is a relative maximum of f if the first derivative, f prime, is positive on the left-hand side of c and negative on the right-hand side of c. F of c is a relative minimum of f if the first derivative is negative on the left-hand side and positive on the right-hand side. So let's take a look at an example. Clearly, when I look at this function, this is a relative maximum. If we were to look at the derivative on the left-hand side, all the points on the left-hand side, f prime of x would be positive. If I were to look on the other side, I'd see that f prime of x is negative. So when we have a bump, or when we have a relative or local maximum, the slopes are going to be positive on the left and negative on the right. On the other hand, if we have a local minimum, it's going to go from negative to being a derivative that's positive. In effect, if we need to find these places, we can take the number lines that we created in the last section, look at where things go from positive to negative or negative to positive to tell us whether we have a local maximum or a local minimum. In this example, we want to find the values of those relative extrema of f of x equals x cubed plus 6x squared plus 9x minus 8. So we're basically going to carry out our first derivative test, but we're going to add in the one little extra thing that we're going to look at how the derivative changes on those number lines. So first off, we need to take the derivative of each one of the four terms. The derivative of x cubed is 3x squared. The derivative of 6x squared is 12x. The derivative of 9x is plus 9, and the derivative of negative 8 is 0. So that gives us f prime of x equals 3x squared plus 12x plus 9. Now we're going to go ahead and set that equal to 0. We don't have to worry about it being undefined because this is a polynomial, and polynomials are defined everywhere. So I'll go ahead and factor out a 3 in front. That leaves me inside x squared plus 4x plus 3. And now since that's a trinomial, I'm going to factor that even farther into 3 times x plus 3, x plus 1. Notice that my inside term is 3x, my outside term is 1x. Those combine to give me the 4x. If we set each one of the terms equal, each one of the factors that is, equal to 0, we get x plus 3 equals 0 or x plus 1 equals 0. So our critical numbers are at -3 and -1, and I can go ahead and label those on my number line for the first derivative. Now let's go through our testing. We need to test in each one of these sections. So I'm going to try picking -4, -2, and 0. When I put -4 into the derivative up here, I'm going to get 3, which is positive. When I put -4 into the next terms, I get -1, so that's a negative term. And when I put it into the last term, I get a negative number there also. So positive times negative, overall, that's going to be a positive. When I put -2 into each one of these factors, the 3 is positive. -2 into x plus 3 comes out to be positive. And -2 into the last term comes out to be negative. So positive times negative, overall that's a negative. Now when we put in 0, each one of the factors comes out to be positive. So overall, that's positive. So we know the function was increasing until -3, decreasing from negative till -1, and then after that it was increasing again. So we see that it went from positive slopes to negative slopes, so that must be a relative maximum at -3. It went from negative to positive at -1, so that must be my relative minimum. It asked me to find the values of the relative extrema. That implies that I need to know what the function values are. So if I go ahead and find f of -3 and f of -1, that'll tell me exactly what those y values are. When I put -3 back into the original function, that ends up giving me -8. And when I put -1 back into the original function, that gives me -12. So my relative maximum is at the point -3, -8, and my relative minimum is at -1, -12. Let's try this process again, but let's now use the function f of x equals x squared times e to the x. We're going to need to go ahead and find our derivative again, but this time we'll use the product rule with the u being x squared and the v being e to the x. So when I take my derivative, I have v, which was e to the x, u prime, which is 2x, plus u, which is x squared, v prime, well, the derivative of e to the x is e to the x. Now let's do a little bit of algebra on that. So I've noticed that there's a common x in both of these terms and a common e to the x, so I factored out x e to the x. That leaves me inside of the parentheses with 2 plus x. Now I can set these factors equal to 0. E to the x is never 0, so either x is going to be 0 or 2 plus x is going to be 0. So that's what I've written out here to the right, that x plus 2 is equal to 0 or x is equal to 0. So if I subtract 2 from both sides, that leaves me with x being -2 or x being 0. Now I can make out my number line and do my testing. So I have my number line, and I'm going to be testing the first derivative. I've labeled my critical numbers -2 and 0 on the number line, and I've written equals 0 above them to indicate that I got these critical numbers by setting the derivative equal to 0. I need to go ahead and test in the first interval at a place perhaps -3, in the second interval at perhaps -1, and in the third interval at 1. So if I go ahead and put negative 3 into each of these three factors, negative 3 into x is going to give me a negative. E to the negative 3 is always a positive number. And 2 plus negative 3 is negative. So I have negative times a positive times a negative. That gives me a positive. When I test at negative 1, I'm going to get a negative 1, so that's negative. E to the negative 1 is positive. 2 plus negative 1 is also positive. So negative times positive gives me negative. And when I put 1 into those three factors, I get positive times positive times positive. So overall, that's positive. So looking at my number line, I had positive, which meant we were increasing, and then negative, so decreasing. So I have a relative maximum at negative 2. I went from negative derivatives to positive, so that means I had a relative minimum at 0. So I now know the location of each one, and if I need to know the y value, then I'd go ahead and plug negative 2 back into the function and get the value for that, and I'd put 0 back into the function and get the value for that. You can go ahead and put those into your calculator and get those values yourself.